Hello guys, in this video I'm going to talk about C# record types. It is one of the new features of C# which was introduced in C# version 9, and it's very useful feature, especially when we need to represent data in our applications such as database models or API responses like DTOs, and it's also a very useful feature when we need value-based equality. I'm going to talk about value-based equality in a moment, but for now let's just focus on creating record types. So I've already created a record type for this tutorial, and it is a record to represent person data. Here this syntax, this parenthesis here is called primary constructor, and all these parameters within this parenthesis like first name, last name are referred as positional parameters. And when we declare record type, behind the scenes compiler generates a class for us, and all these parameters are going to be the properties of this class. Actually, we are going to take a look at what compiler generates for us in a moment, but let's now talk about other features of record types. Another feature of record type, records are immutable. So once we create an instance of record and give the value to the properties, we cannot change them. Now let's go ahead and create an instance of this record. For example, P1, person 1, new person. Now let's give it first name, last name. So why these parameters are called positional parameters? Because we need to give the values to the parameters in the same order that are declared in the records. And as I mentioned before, records are immutable. If I try to change one of these properties like last name or first name, compiler is going to give us error, something like init properties, init only properties can be assigned only in a object initializer. And another feature of record types is it behind the scenes automatically overrides toString method. That's why if I invoke P1's toString method, it will print all these properties and their values. Let's just check. As you see here, person, first name, last name is listed. On classes, by default, when we invoke toString, it invokes the object class toString from object class, and it just print out the name of type. But here, for records, compiler implements toString method and it prints all these fields. It is useful thing for debugging purposes. So another functional feature of record type is they have value-based equality. They provide value-based equality. What it means, if I create another record with the same values, like with the same first name and last name, for example, within if statement, if I check P equals P2, so it's going to return true in this case because their values are same. But if I change here any of these property values, in this case it will return false. They won't be equal. Let's just type it to the console like P1 equal P2. Now we can see it is false because here we have last name on P2 Alizada 1, that's why it returns false. But if I make them equal, like both Hussein Alizada, in this case this statement is going to return true. So it's called value-based equality. Now let's just take a look at what compiler generates for us when we declare record types. For that we have some tools like ILSpy, Dotpeak. Personally I like to use Dotpeak. That's a tool, free decompiler from JetBrains. You can install this tool from JetBrains site, and it's just quite easy to install. Now let's just open Dotpeak and take a look at what we have on generated source code. let me open the assembly learning records.exe, and in this file, actually if you install .pik by default, it's not going to show you compiler generated code. Actually, it's going to show you actual source code which you wrote here, this code, like this record declaration. To enable this functionality, to be able to view compiler generated code, we need to go this tools menu, options, and from here, from the compiler, we need to check this option, show compiler generated code, and then you will be able to see compiler generated code. Now let's check, let's expand these learning records, and here as you can see, we declared our record in this namespace learning records. That's why let's open this learning records. Here we have person type, and if you right click and click here the compile source code, we can see generated compiler generated source code. So here, as you can see, compiler generated class for us, class person, which implements iExecutable interfaces, and it has a method equals, and here let's take a look at the implementation here. On this, as you can see, it compares all the field that we declare. In our case, that's first name and last name. So in this case, it also checks types. So if two records are referred to same type, and if their values, all property values are equal, in this case, these two records are considered equal. So this method, in this case equals, is going to return true. And let's check another compiler generated codes for this class, for this record. So we have here backing, private read-only backing fields for first name and last name, and we have naturally properties here for first name, last name, and here we have init modifier. That's why records are immutable, and also we have toString implementation here. It's overridden here, and it invokes print members, and print members just takes all these fields and their values, combine into a single string and return. Let's see what we have here. I think that's all. And also there's a deconstruct method. I will come to this later in this video. But now let's take a look at record bodies. As I mentioned, records are immutable. Once we create an instance of a method and gives a value to parameters, we cannot change it. So, but actually if we declare body for this record and declare property on that, we can easily change it. So to declare body, just need to add curly brackets, and here we can declare properties like in usual classes. Let's see, for example, let's declare an int property age. Now when we create new instance of person record here, we can use object initializer syntax, and we can give value to age property, let's say 20, and after that, for example, we cannot change last name or first name. Compiler is going to complain about this, but we can change like body parameters. In that case, let's just remove it. So also we can also declare here methods, like any methods, but it's not recommended. If you end up adding methods or some business logic to your record, it is better to use usual C# class than records. Record is very useful when you need to represent data such as database models or API response, DTOs. Now let's take a look at inheritance in records. Actually, inheritance is quite straightforward, like in classes. So let's say we want to create new record and we want to inherit this record from person record. For this, let's declare another record, let's say public record, great person. It will also have the same parameters like first name, last name, and let's add additional parameters. Since it's a great person, let's add achievements. And to inherit from an existing records, we need to use this syntax and then provide the name of record that we want to inherit from. Then we need to pass parameters to the constructor, to the primary constructor here. So that's the syntax for inheritance in records. And one more note, one more thing, we cannot inherit a record from a class and vice versa. Class also cannot be inherited from a record. For example, if here we create a class, let's say public class, test class. So if we try to inherit it from record, compiler is going to complain about this, like only records may inherit from records. And same for records. Records cannot be inherited from class. For example, here if I try to inherit it from test class, I will get the same error. So that's inheritance in records. And last thing, let's take a look at serialization in records. So actually it is quite straightforward and it works as in classes. Now let's say we want to convert this record, actually we want to serialize this record into JSON. So for that we can use JSON serializer from system.text. Here we have the serialize method and we can pass it, and then let's assign it to some variable, to this JSON string. Let's call it person text. And if you console write line this, so it is converted to JSON. And one more thing, if you want to change property names, field names on generated JSON, like for example here we have last name, but let's say we want to change it to surname when we serialize it to JSON. For that we can use a JSON property attribute like in normal classes, but there is some detail here. Let's take a look. So JSON property name, let's say we want to call it surname. But you see here compiler complains about this. So it says attribute is not valid on this declaration type. It's only valid on property indexer field declaration. To solve this issue, we need to add a target to this property. So for that, we can just type property in the wrong place. Yep, that's it. So now issue has been resolved. If I run application again, I will see last name became surname. I think that's all about records. Thank you for watching my videos, and if you like this video, please do not forget to subscribe my channel, and see you on the next videos.